Next one is area and perimeter on the coordinate plane. It's going to be under analytic geometry here. Alright. Find the approximate perimeter of Polygon Dingo below. Alright. So, one thing right off the bat that we can get out the way is we can count this. Since it's a completely straight line and not diagonal like these, we can completely count how many this is. So 1, 2, 3, 4, 5, 6 across. So there's one of our measurements out the way. Since it's perimeter, there's all we're doing is just adding up all of the sides here, but we do need to do some formulas using triangles here to be able to find our values of these, because I'll just count how many spaces like this. You can't exactly do that. So let's use triangles. Alright, so let's find this top one first. Really, we only need to find one of these and times it by 2 because we got one on the other side. So let's just find one of these on each side. So let's do this top one first. We have 6 across the top here, and then 7 high. So that's going to look like 7 squared plus 6 squared equals c squared. As you can see, I'm using the Pythagorean theorem to be able to find this value, since it's distance using triangles. 49 is what 7 squared is, plus 36, which is what 6 squared is, equals c squared. 49 plus 36 is going to give you 85. Now let's square root both sides. C equals square root 85. Alright, so we know this part is square root of 85. So that's one of our values. We can't really simplify that in radical form as far as I know. So let's just keep it square root of 85. Next piece, let's do this part. So we got 4 down and 3 across. So this is going to look like 4 squared plus 3 squared equals c squared. So 4 squared is 16 plus 3 squared is 9 equals c squared. 16 plus 9 is going to give us 25. Now if we take the square root of both sides, we actually get a nice pretty number here. The square root of 25 is 5. So let's write down what we know. So we got our 6 at the bottom plus square root of 85 plus square root of 85, because there's another one on the other side. The same thing with the 5. We got 2 of them. And it's saying round your answer to the nearest hundredth. So let's put this in a calculator and let's see what we get. 6 plus square root 85 plus square root 85 plus 5 plus 5. And we get an answer of 34.44. 34.44. Alright, this one's asking for area this time. So area of a rectangle. So again, let's note area of a rectangle is base times height. So we really only need to find our base and one of our heights. So, of course, we gotta use triangles for this to find out distance between these 2 points. Because we cannot just, flip this on its side and start counting this way, because you just can't do it. So 6 plus 6, that's going to give you 12 across. and 1, 2, 3, 4 up. So it's 12 squared plus 4 squared, which that's going to give you 144 plus 16. And that's going to give you square root of 160. Now let's simplify this radical in here. So we can actually simplify this radical down here. So to do this, we need to make a factor tree of it. So 160. Since 4 is a perfect square and it goes into 160, I'm going to use that. So we got 4 times 40 will give you that. If we keep going, this can split up into 2 and 2. Then 40, let's split that up into 20 and 2. This can be 10 and 2. And we can technically just leave it like this. So, here's our pairs here. We got 2 pairs of 2. So 4 would go outside your radical because of 2 times 2. And then what stays in the square root is going to be 10. Because that's the one just kind of hanging off the tree here. It's not really doing much for us. So this stays inside the radical and we just don't really do much with it. So now let's find our height we're calling here. So 1, 2, 3, 4, 5, 6 tall and 2 across. So we got 2 squared plus 6 squared. That's going to give you 4 plus 36, which is square root of 40. So if we were to factor tree this, let's go ahead and erase this part here. So we could do 40, split it up into 20 and 2 again. We can't branch off the 2, so let's do 10 and 2, and then 5 and 2. So we found 1 pair of 2. So the only thing that's going to go outside the radical is the 2. And then, since, again, 5 times 2 would stay on the inside of the radical, since it's just hanging here and it's simplified as much as it can be, let's just keep it 10. Alright, now that we got both of these, now it's just a simple base times height. So 4 square root 10 times 2 square root 10. And it's saying to round to the nearest hundredth, so 2 decimal places. Alright, so 4 square root 10 times 2 square root 10. And that gives us a perfect 80. 80 units squared.